Section 8.2, solving linear systems by elimination. Okay, so this section, well, in the previous one, quickly we just did the substitution method, solving algebraically through substitution. And now what we're going to do is solve algebraically through elimination. So again, you're going to have two equations and two unknowns, and we're just going to set it up by either subtracting or adding the two equations. So this is possible, and that way we're going to eliminate one of the variables. Okay, so let's just read this paragraph and we'll jump into a few examples and take a look. Okay, so recall the substitution method was used when one variable had a coefficient of 1. One variable was easily isolated. The elimination method can be more effective when no variable can be easily isolated. So no variable has a coefficient of 1. The purpose of the elimination method is to line up the variables with the same coefficient, so upon addition and subtraction, the variables can be eliminated, leaving only one variable in one equation. Okay. So example 1 here. Okay, so it says solve the linear system by elimination. Okay. Again, you get your two equations, and then we got our marker here, right? Let me see if I can use this. To highlight. Okay, we'll just use this. Okay, so we got our first equation here, 5x minus 3y equals 19. Our second equation, 5x plus 4y equals 33. Okay, so you can see that, well, the first step is you're going to line it up so all the similar terms are on top of each other. So 5x, 3y, and you got 4y here, and you got just the whole numbers here, the integer form here. And if you can see that if you subtract, you can either subtract or you can add the equations. Okay, if you subtract the equations, okay, make sure that the negative is going to go to every single term in the equation. Okay, so for example here, 5x minus 3y equals 19 minus the second equation. Put everything in a bracket, so this negative goes kind of bombs into each term. So negative 5x, 4y becomes negative 4y, and 33 becomes negative 33. And then you just simply go down and collect like terms. So 5x minus 5x is 0. So this is the elimination portion of it. We're getting rid of the 5x. Negative 3y minus 4y will give us negative 7y, and 19 minus 33 will give us negative 14. And now simply isolate the y by dividing the negative 7 on both sides. Y equals 2. Okay. Once you solve for y, you can just plug it into either one of the original equations, doesn't matter which one, and then you can just solve for x. Okay. It's pretty simple. So let's try this similar example in example 2. Equation 1, 6x plus 7y equals 23. And then you got example 2, equation 2, 2x plus 7y equals 31. Okay. And then the elimination step, simply, again, decide if you're going to subtract or add. Here we're subtracting because 7y minus 7y will eliminate it. If we decide to add the equations, 7y plus 7y will get 14y. So we don't get to eliminate anything. So we need to eliminate one of the variables. That's why we're subtracting. Make sure the negative goes to everything in the term. So 6x minus 2x will give you 4x. 7y minus 7y equals 0, so nothing there, so eliminated. And 23 minus 31 gives us negative 8. Okay, and finally, just isolate the x, divide 4 both sides, x equals negative 2. The negative 2 here that we solved, just plug the x negative 2 into either one of the equations, and you'll get the y point here. And then the solution here is here, right there, point negative 2, 5 for the x and y. Okay, here's an example 3, where we're going to use, we're going to add the equations and not subtract it. Okay, so, whoops, not highlight everything, but example, or equation 1, 3x plus y equals 17. And equation 2, 2x minus y equals negative 2. Okay, so you can see that if we added the y's, or we added the two equations, we have this y plus negative y, which is 0. But if we subtract it, we would have had y minus negative y, which would have been 2y, right? Because negative and a negative is a positive. So that's why we're adding the equations here. Okay. And then basically after that, once you've eliminated the y, then you can solve for x, and you can plug the x into either equation to get the y. Okay. So hopefully this section here kind of makes sense. But what if it wasn't so nice? So you can see that the coefficients of y here, so the number next to the variable, were both 1. and then here's 7, both 7. Here, x both had 5, so we can simply just add or subtract, and it gets eliminated. But what if it wasn't lined up so nicely? What if the coefficients weren't identical? What would we do there? Okay, so let's look at the next section here. Okay, so here, I'm just trying to ignore the 3 here for now, but first equation, oops, let me see if we can just highlight the starting here, or equation, okay. So you get first equation, x plus 2y equals negative 4. And the second equation, 3x minus 4y equals 18. Okay. So we can add or subtract the two equations together. That's fine. We can also multiply an equation by a number, a whole number, or a fraction. It could be a fraction, but we're going to probably deal with whole numbers here. So we can multiply an equation by a number, and the equation is still an equivalent equation. So it's not like we're changing the equation to be something different. It's just in a different form. So in this case, they're multiplying the entire first equation, x plus 2y minus 4, by 3, right? So, and that's only true, like, it's still an equivalent equation if you multiply every term by 3. You can't just multiply one part of it. So 3 times 3 is 3 times x is 3x, 3 times 2y is 6y, and then 3 times negative 4 will give you negative 12, which is the equation right here, right? So they just rewrote it. So why did they choose to multiply by 3? Because if you multiply by 3, now you can see the x's are the same from the first equation, right? Just rewritten this way. And the second equation. Okay, now we can just either add or subtract. And in this case, we're going to subtract. So 3x minus 3x will get eliminated. And then you get your 6y minus negative 4y, which is going to be positive 4y. That's how you get 10y. And negative 12 minus 18 gives you negative 30. Y is negative 3. And then you simply just plug it in to either formula, or you can also plug it into, well, yeah, you can just plug it into either formula, or you could, if you had a simplified formula, you could do that as well. Okay. This is one way to solve it. You could have done the same thing with the y's and eliminated the y instead of the x. So for example, instead of multiplying everything by 3 here, you could have multiplied everything by 2, right? So then you would have had 2x plus 4y, right, minus 8. And then you could simply add the two equations to eliminate the y, and then you can solve for the x, right? And then plug the x back in. So there's a couple ways you can do these equations. Yeah. Okay, we'll go through the next two examples. We still have time. It's only been 7-8 minutes. So here we have equation 1, 2x minus 5y equals 29. And then equation 2 is 3x plus 2y equals 53. Okay. So you can see, how can we multiply the equations to be equivalent? So in this case, we can multiply both equations, right? So you can see by the opposite coefficient. Okay, so this has 2x, this is 3x. So simply, if you want the x's to be the same coefficient so we can eliminate the x, you multiply the bottom equation by 2 because there's a 2 on the x, and the top equation by 3 because there's a 3 on the x. Because if you do this out and rewrite both equations here, so equation 1, you can see if you multiply the 3 in, you get 6x, 3 times negative 5 gives you negative 15y, 3 times 29 gives you 87. And equation 2, 2 times 3x gives 6x, 2 times 4 equals 4y, 2 times 53 gives 106. Once you've written these two equations out, right, now you just decide, are you going to add or subtract these equations? Okay, don't look at this right now. But they decided they're going to add this now because that's how you eliminate the x, right? 6x minus 6x gives you 0. If you added them, it would have 6x plus 6x would have given 12x. Okay. Just note that this negative, again, it applies to everything on the second equation, okay? So 6x minus 6x is 0. Negative 15y minus 4y is negative 19. And then 87 minus 106 is negative 19. Isolate for the y. Plug it into the original equation. Either one, doesn't really matter. And solve for the x. And then your solution is right there, 17.1. Okay. Okay, next example, same sort of thing here. So you got 7a 7a plus 3b equals 47. 2a plus 5b equals 30. So multiply it by the opposite coefficient on the same variable. So this has a 2 here on the a, so we multiply by 2 on the entire equation. This has a 7 next to the coefficient a, so we multiply the second equation by 7. And then you get your equation 1 right here, rewritten as this, and equation 2, oops, it's not wanting to do that. Equation 2 rewritten out like here, right? So 7 times 2 is 14a, 7 times 5 is 35b, 7 times 30, 210. Okay. And again, now we're going to subtract so we can eliminate the a, and then we can eventually solve for b, plug in the b in, and to get the a. Okay. Hopefully that made sense. Okay. Other than that, that's pretty much the only new material. So in part B, remember what we talked about in substitution in 8.1? When you have your two equations, before you do anything, make sure you simplify the equation. It'll make your life easier. You don't have to do a simplify step, and you can just jump into it, but then that would take longer, and there's more chance of errors as well. It can get kind of messy. So here we got our two equations. Oh, cool, I got a little pen now. Okay, so 3 times x plus 1 and minus 5y minus 2 equals 22. Equation 2, rewrite here. So just simplify it. So just multiply the 3 in. So, right, 3x times 3, 5, and it's negative 5 multiplies into everything in the bracket. So negative 5y, my positive 10, and equals 22. And then do the same thing for equation 2, right? So you can see multiplying it in. And now, so this equation 1 is rewritten right here, and equation 2 is rewritten right here. Okay, so that way we can work, now we can work with the equation 1 and equation 2, and it won't be as messy and less chance of error here. Okay, so now these two equations, how do we do the elimination step? So the x's have different coefficients, the y's have different coefficients, so we're going to have to multiply the equations. So what could we do? So we can get the x's the same if you multiply this entire equation by 2, whoa, by 2, and then the second equation by 3, because 3 is over here, right? So, and that's what they're doing here, right? Rewriting it again, okay. And finally, we got equation 1, equation 2, and we can see if you want to add or subtract, and we want to, in this case, we want to subtract to eliminate the x, and we can solve for the y doing some basic algebra, and plug this y into one of the equations, and you can get your x, yep. Yes, we are doing the same thing for example 2. For example 2, the thing that you have to, I guess you can see, is we're dealing with fractions here, right? So fractions in the first equation, fractions in the second equation. So before we go into the elimination step, we should probably simplify. Okay, so how do you get rid of a fraction here when these two terms here? We're going to find the LCM, the lowest common multiple of 6 and 4. So what you're going to do, just you can write out multiples of 6, so 6, 12, 18, 24, and then we can write down multiples of 4, 4, 8, 12. What's the lowest number that they both have in common? In this case is 12, okay? So that's why they're multiplying the entire equation by 12. So 12 times x over 6, so it's going to end up being 12x over 6, and then 12 divided by 6 is 2, so they get, that's how they got that 2. And 12 divided by 4 gives you the 3, right? So 3y from this fraction. And then finally 12 times 6 is 72. Okay. So that's how they got this equation are equivalent equations, just written down in a more simplified form to get rid of the fractions. Okay. So step 2, rewrite this equation without fractions as well. So again, what's the LCM of 6 and 3? You can write out 6, 12, 18. 3 is 3, 6, 9. 12, 15, 18, and then both have the lowest common multiple as 6. So we multiply the entire thing by 6. So 6 times 5 gives you 30. 30 divided by 6 gives you 5. So that's how they got that. 6 divided by 3 gives you 2. So no negative 2 in this case because of the negative sign. Negative 2. Finally, 6 times 11 gives you a 66. Okay. So we got our two equations rewritten without the fractions, and now we're getting ready for our elimination step. So you can see that the x's and the y's don't have any common coefficient here, so we can't simply just add or subtract. But what we could do is we can, again, like how we did previously, multiply this entire thing by 2. I think, well, I guess they're trying to eliminate the y here, so because there's a 2 on the y, so multiply the entire thing by 2. And then since there's a 3 on this y, multiply the second equation by 3. Okay. And you're going to rewrite that, so 2 times 2x is 4x, 2 times 3y is 6y, 2 times 72 is 144, 3 times 5 is 15x, 3 times negative 2y is negative 6y, and finally 3 times 6 is 198. Okay. So we rewrote the equations again. Finally, now, the last thing we need to do when we eliminate is decide if we're going to we're going to subtract or add the equations. And we're going to add the equations here because we have opposite signs here for the y. We're trying to eliminate the y. 6y plus negative 6y will give us 0y. 4x plus 15x gives us 19x. And 144 plus 198 gives us 342. Isolate the x by dividing by 19 on both sides. X equals 18. Excuse me. Once you got that, plug this x into, you can plug it into any of these equations. Okay, the further back you go, the better. Like if you plug it into the original equations, it's the best because you'll know in case you made a mistake later on. But at the same time, if you plug into the original equations, you're gonna have to do a bit more work, right, because of the fractions. So in this case, I doubt they do that. They plug it into the more simplified equation. So you could take this x equal 18 and plug it into any of these equations, and then you'll get your answer here. Or you can plug it in x equal 18 into the equations we made up here as well, right? And then you could solve for y. Yeah. Hopefully that made sense. Okay, so there's more questions on here with all the completed work. So if you want to practice it to what we're talking about, we have examples here. You can work through them if you like. And the answers are written here as well. But yeah, so 8.0 was our review. 8.1 was the substitution method. 8.2 we talked about the elimination method. Tomorrow I'll move on to 8.3, which is word problems. Your test reminder is going to be on Wednesday on chapter 7 and 8. Yeah, okay, so after watching these videos, we can move on to the homework, and as always, give me a message on Teams if you have any questions on, well, anything really, but in particular, chapter 8, section 8.1 and 8.2.